In today's video, we're going to talk about object pooling, what it is, and why you might want to do it. And we're going to build this little example project to show kind of the benefits of that. And as you can see, this little spaceship can shoot mega amounts of bullets and no noticeable performance impact. And we'll show you how we did this in the video. All right, well, welcome everybody. So today we're going to talk about a programming pattern that's pretty commonly used in video games, maybe a little bit less commonly used nowadays than it used to be, but this pattern is the object pool pattern. And the pattern is designed so that we reuse objects instead of creating them new instances and destroying those instances on a regular basis. And, you know, as this example here, like having a bullet bucket, I've got my bullet object pool. And instead of making new bullets, you see I've just got 5 and the ship is cycling through them. And obviously this is kind of a dramatized or animated version of what's happening here, but you can see that when the bullet reaches the end of its life cycle or maybe leaves the screen or something like that, then it leaves the active duty of a bullet and it goes to the bullet object pool. And then the next time the ship fires, it just pulls the next bullet from the pool. Okay, so that's kind of a visual representation of how an object pool works. A couple reasons why this might be implemented or used is to improve performance. You know, in Unity, from experience, I know that when you have lots of objects that are deleted, then you have what's called a garbage collector, because they aren't deleted at the time they're deleted. They kind of remain in memory. And then, so let's say you have thousands of bullets, it might build up to hundreds of thousands before the garbage collector comes through and cleans up that memory. And that frame where it cleans the memory is going to be pretty slow if the quantity is high, for example. And so you get like a hitch in the game, right? Like a stutter frame or something like that. Okay, so that an object pool can be used to kind of help avoid that. That's a little bit less of an issue in Godot, I will say, and that's because the way Godot handles memory, it doesn't require a garbage collector, at least not if you're using GD script. And instead, when objects are freed, they're freed kind of instantaneously. But in situations where you're creating and removing large quantities of scenes or objects each frame, then you will start to see slowdowns. So we'll kind of cover that in the example we'll go through today. So obviously that minimizes lag spikes from frequent instancing. This can help you manage memory as well, or keep gameplay smooth. So those are a few of the benefits that you might see. And a common place where object pools are used are things like my obvious bullet example here, if you've got lots of things flying around. Explosions or particle systems, if you're making your own kind of particle-like effect. It can also be used for things like enemies or other entities in your world that might need to spawn and despawn on a regular basis. You might just have a pool of those. And now, you know, audio is an interesting example. I've not worked with a object pool for audio playback, but I could definitely see how that would be something that would be useful. Again, in a situation like these bullets, you wouldn't want to have to like load and free audio files for the bullet sound effect. You know, you might just want a way to be able to pool or play back those sounds easily. And then lastly, another example might be for user interface kind of situations where you have pop-ups or alerts or something that's showing up on the screen. All right, so now that we know what an object pool is, let's work on this little example scene as we build a basic version of an object pooling system. So I've got this ship here, and I'm going to build maybe a shmup, a shooter kind of game, bullet hell kind of game, something where I've got a lot of bullets and objects flying around the screen, okay? So I've got this simple scene set up. I've got a ship with particle effects just for fun. I've got this nice realistic space background and a world environment for some glow effects. And I want to start hooking this up. I've also created a simple bullet instance, the same one that was used in our blackboard, okay? And this bullet has a script attached that just causes it to fly through the screen. And actually, I'm going to go ahead and comment that out and make some changes here. So we're going to kind of test 2 different ways of doing these large numbers of bullets and show some of the effect that it can have. But this is pretty straightforward, right? On the physics process, we're just moving the bullet in a direction, which currently is set to vector 2 up, which means it's going to move up on the screen. So pretty straightforward. And then if it moves a certain distance, then it will free itself, okay? But before we can really get going, we need to go back to our scene here, and we need to make it so that we can actually fire a bullet. Okay, so let's go into our script. And this is a pretty straightforward and simple script, but I'm going to go ahead and grab a reference to this bullet scene because I want to be able to instantiate that. All right. So there's our bullet right there. And then let's just go to our, maybe our ready function and begin there. And for fun, let's just go ahead and instantiate a bullet and kind of see what happens, I guess. So we'll just say variable bullet of type bullet equals new, and then, or not new, but what do we want to do? We want to take our bullet scene, I guess. Let's see, bullet. Oh, it's just called bullet, all caps, yeah. Dot instantiate. Okay. And before we can really do anything with this, we need to add it to the scene somewhere. So I'm just going to say add child. So it'll be added as a child of this scene that the script is on, which is this, just the object pooling example scene I've got here. So we'll just add the bullet to the scene like that. And actually, one other thing we need to do is we probably need to position this bullet at the, kind of at the origin of where the ship is, right? So that it's right down here. Okay. And I do have a bullet spawn location. So let's go into our script and let me just grab that right there. So then we can take our bullet and we could say bullet dot global position equals, and then we can just do the bullet spawn location dot global position. Okay, now we should be able to run this scene and see a bullet fly out of our ship. There we go. One bullet. Pretty straightforward. Now let's assume that we want a bullet every time we click. Then we'll go ahead and we'll just add like an unhandled input function here. And of course, what this does in Godot is every time a button press is detected by the script that hasn't been handled previously, then we can respond to it. So I've already got a click action set up in my project settings. So I'm just going to say, I'll say if event dot is action pressed, I guess, right? And then click. Then what we'll do is we want to spawn one of these bullets. So I'll just copy this. Let's put a pass in my ready and just paste it in here into my unhandled input. So now if I run the game, I can click and a bullet flies. Okay, so every time I click, I get a bullet. And that's only going to happen as fast as I can click, right? In Godot, you're never going to run into an issue with something like bullets with spawning them at this frequency, especially because we are destroying those bullets. In fact, let's just look at the script for our bullet here. So we are queue freeing. Let's go ahead and just add a print so that we can see. Now I'll call it free. Destroy is like a Unity kind of terminology, right? So free bullet. And now when we go back to the game view, you can see we're going to start seeing some free bullets. So that's when the bullets are getting destroyed. And so those bullets aren't staying. In fact, if we look at our remote debugger, we should see bullets getting spawned and boom, they get destroyed once they leave the screen. And I did that in a very simple fashion. I just, as the bullet's moving, I just keep track of how far it's moved. And if the distance that it's moved is greater than 1500, because I figure that means it's going to be outside the screen based on the position of my ship, then I destroy it. You may want or need a more complicated way to detect if the bullet should be destroyed than this, but for the demonstration purposes, we just need a way to destroy it, okay? And in fact, if we wanted, we could change this to like 500, or let's just make it 400. And if I save that and go back to the game, now you can see it's only going to travel 400 pixels before it gets destroyed, all right? So you see kind of how that's working. I'll set that back to 1500, and we'll go ahead and save that. Okay, so we have a basic scenario set up, but as we've seen, not a lot of need to necessarily add an object pool at this point, right? So maybe let's create a situation where we do want an object pool. So let's go back into the script, and I'm going to adjust this so that we're firing lots of bullets at a large quantity each frame, okay? And so in order to do this, let's see, let's go ahead. I'm going to make a couple variables here. I want to keep track if I'm firing, so I want to make it so if I'm holding down the button, I'm firing, and when I let go, I'm not. So I'm just going to make a simple variable called isFiring, which is a Boolean, which by default will equal false. Okay, I'm going to take this code here, and we're going to put this into a new function that we will call maybe spawn bullets. Because as you will see, we're going to progress from a single bullet spawned to many bullets spawned. Okay, but for now, we'll just do one bullet. Okay, and I'm not actually going to call spawn bullet or spawn bullets in here. What I'm going to do is I'm going to set isFiring to true, just like that. And then what we can do is when we release the mouse button, then we can set that isFiring to false. So we'll add an elif, event.is action released, click, then is firing will equal false, just like that. Okay. Now what we'll do is let's add a process function. So the process or not the process, but physics process is actually what I want. So what physics process does is on every physics tick, which is set to like, 60 frames per second, then this will happen. So that means 60 times a second, we should be able to spawn a bullet if we use this properly. So we'll just say if is firing, then we will call spawn bullets. Okay. Now we're going to add on to this so that it gets kind of crazy here, but let's go ahead and just save this and let's run the project. Okay, so now when I'm holding down, it's spawning bullets and then it's freeing them. I want to go to my bullet script actually, and I want to remove that print because that will slow down the game, printing to the console like that. Okay, so we should no longer see the free bullet, but we could check our remote and you'll see that these stack of bullets will disappear eventually, right? Okay. And now you can hold down to get a lot of bullets. We're still not noticing anything too crazy though. So let's go back to our script and look at our object pooling example. Now when we spawn bullets, let's just make it spawn a lot more bullets. Okay. And in order to be able to see this, I want to spawn them kind of in a spray, like a spread pattern. So we're going to update our spawn bullets function to provide like a direction and an angle. Okay, so let's say variable underscore dir, or we can just call it dir, it doesn't need an underscore. This will be a vector2, and by default, we'll set this to vector2.up. Okay, now what we're going to use with this direction is, if you recall looking at the bullet script I showed you earlier, we do have a move direction, and we do use that, you can see in the physics process, to determine which direction the bullet should move. So we'll calculate a direction, and each bullet that we fire will give it a different direction. Okay, so we'll start with that. In order to rotate this and make this work kind of in a nice seamless fashion, I'm going to give this an angle variable, and an angle is as a float, I guess. Okay, and what we can do is we need to determine maybe how many bullets we want. Let's start with another variable that we'll just call like count, and this will be an integer. And let's set it equal to 3, just so we can start seeing how this works. So our angle, I want to rotate it so that they are evenly spaced and so that the middle one is pointing up. And so what I'm going to do is I'm going to calculate an angle based on the bullet count, or half the bullet count actually, so that it goes halfway to up and then continues to go. I don't know if that made sense, but what we're going to use, because angles by default are in radians, but degrees are easier for my brain to work with, I'm going to use this degree to radian. So we're going to calculate a radian angle based on a degree. And let's just say that the spread angle should be like, let's start with 10 degrees. Okay. And then we'll multiply this by the bullet count. No, the count, I just called it count, times 0.5. Okay. Oops, I didn't put my little time symbol in there. So I did add that. That's what I did. Okay. So now we're going to create multiple bullets is what we want to do. And we're going to calculate some angles and a direction. Now we can't just simply instantiate a bullet like this. What we're going to do is we're going to loop through the count. So we'll say for I in count, not in count, but I in count. Right now what we're going to do is we're going to create a bullet. So this will create 3 bullets. We could increase this and we'll show that in just a second. But we also want to, with this bullet, we want to set our move direction. So bullet.move direction equals. Now here we need to calculate a direction, and what we'll do is we'll say dir dot rotated by, and we'll just pass in the angle here. And actually what I want to do, I think I should start the angle negative so that it starts one way and then rotates around. Okay, so in order to do that, I'm just going to maybe put a negative sign in there, right there, so that the angle starts negative. Okay, so we've got our move direction set, we've got our position set, we're going to add the child, and then after each bullet is spawned, we need to increase or change the angle so that for each bullet it changes, right? So we'll say angle plus equals, and then we can say degree to radian, and then we'll just pass in that 10. In fact, we're doing this twice here. So let's go ahead and actually just calculate that. We'll say variable rad angle float equals, and then I'm just going to grab that, boink, and then we can put in here our rad angle because it's totally rad. Negative rad angle, and then here we'll just add the rad angle. Okay, save that. And hopefully my game is still working. There we go. Looks like I got my math a little bit off somehow, but you can see now that we're spawning 3 bullets. And if we look at our debugger, we've got a lot more bullets spawning. The numbers are getting pretty high on those, right? But it's not breaking yet. So let's keep trying to break it. Okay, let's increase maybe the count to something higher like 10. Let's go ahead and save that. Go back to the game. Pew, 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 pew. That actually looks pretty stinking cool. Let's go back and let's put the count. Let's put the count even higher. Let's make it 60. And I'm going to decrease my angle that I rotate it to a smaller amount. Okay, so we'll just cut that in half maybe. Save that. Go back to the game. Now that is sweet looking. But you can see, now watch, it's going to start getting choppy finally. You see that? You see how it's choppy here? Now it'll be, you can tell it's choppy right now because if you look at the little particles for the ship, they're slowing down. And then once it starts clearing them up, that frame rate returns back to normal, right? But you can see that we're getting some slowdown now. Yeah, there you could really see it right there. If I get a couple spaces and then hold it down. Oh man, yeah. It's getting really choppy, okay? So we're hitting the limit of our game's ability to spawn and destroy the amount of bullets we have each frame. Okay, so this is where we're running into that kind of more like a memory limitation kind of situation, okay? So object pooling will help in this particular situation because what we can do is instead of having to instantiate bullets each time and destroy them, if we just have them readily available, that cuts out that little bit of work, okay? So I'm going to go ahead and just stop running the project, and we'll talk about how we're going to implement this object pool next. All right, so in order to convert this script to use an object pool, we're going to build, I mean, it's going to be pretty rudimentary, right? But it should give the understanding and the basic concepts and show how we can implement them in code. So I'm going to take some of these variables that we declared within this function here, like the count and things like that, and I want to abstract a little bit of that and just put it in the root here. So we'll have a variable maybe called bullet count. Okay, and this will be an integer that will determine how many bullets we produce on each call of that function. And then I want to have another variable that I use to limit the number of bullets. And so this will be the max bullet count. So variable max bullet count, also an integer. And this can be pretty high. I'm going to set it to like 30,000. Okay. I did a test previously, and I think we're hitting about 20 to 25,000 of those bullets before we hit the, that limit. So 30,000 should be more than we need by a good number. And then let's go ahead and just set, we've got our bullet spread angle, which was, what was that? What did we set it to? 5, I think. Now there's a couple ways we can implement an object pool. One is a dynamic object pool, meaning when you try to spawn a bullet, if you don't have any in the pool, then you create a new instance and then add that to the pool. And in that dynamic version, then your pool will grow, right? So maybe when you start the game, the player only shoots 5 bullets, and so you have 5 in the pool. But then later in the level, suddenly you've got hundreds of bullets, and so you have to instantiate a few more, or maybe 100 more, right? Or 95. And at that point, your pool is now 100 bullets, and now you can pull from those 100. You're getting kind of where I'm going with this, right? Where you kind of dynamically grow that pool as you go. And that's going to be an exercise I'll leave to you guys to do if you feel it's necessary for your game. But for this, I'm going to work with a fixed pool, meaning we're going to spawn all 30,000 bullets when our game starts. And those bullets will be available to use throughout the game. And we will never have more than 30,000 bullets, meaning if we try to use bullet 30,001, well, then it's just going to take the oldest bullet that's active in our scene and draw that one back, okay? So in order to do this, though, we do want an array to keep track of our bullets. So we'll call this array, we'll call it bullets, and it'll be an array. We'll just make it of that bullet scene like that, okay? And then lastly, I want to keep track of the bullet index, or this is essentially the most recently used bullets index within that array, right? So obviously when we start that integer 0, and the max it'll be is like 2,000 or 29,999, something like that, right? Since our arrays are 0 based. Okay, so there we go. These are some additional variables we need in order to keep track of this. Now, we're going to come down to our ready function, and you could create a function to do this, but I'm just going to do it here. We're going to instantiate, like I said, all of our bullets when we begin. So I'll say for I in max bullet count, we're going to go through and we're just going to create our bullets, variable b of type bullet equals, and then what do we need to do? Our bullet dot instantiate, just like that. And then we need to do those same things that we did previously. We need to add it to the scene. So we'll add it as a child of this scene. We also want to then add this to our bullet pool, right? Which we call bullets. So bullets dot append, and we'll just add b, just like that. And I'm actually going to rename bullets to bullet pool, just so that it's obviously clear what that is. Okay, so bullet underscore pool, because I was wanting to call it there, right? I wanted to call it that when I just wrote that line, so that indicates to me that that might be a better name, at least for the sake of a video. Okay, now one other thing that I want to do is if I look at my bullet script, I do have this reset bullet function, which sets the distance move to 0, makes it not visible. That's the thing that's most important here. And then it stops the physics process, so it's not going to try and process. Okay, so what I'm going to do is I'm going to come here and I want to call this for each bullet. So I'll just say b.reset bullet. Okay, that way when we start, the bullets aren't just like suddenly firing all at once. Okay, because then, I mean, we could do that. That might be fun, but we'd end up with 30,000 bullets on the screen and they'd all be in the same spot moving up. It would just look like one bullet, probably. Okay, I'm going to go ahead and save that. So what this does right now is not going to be obviously clear, because if we run the project, right, it's going to spawn those, but we're still using our old code to shoot the bullets. Okay, so I'm going to stop. So the next thing we need to do is, instead of using this, I'm going to go ahead and comment out spawn bullets, and we're going to make a new function that we'll call spawn bullets underscore pooled. This way we can compare the difference more easily. Okay, we'll keep that old function in place. So let's go ahead and, oops, and I want to copy that. Copy this, and we'll make a new function down here called spawn bullets pooled. Okay, so what this spawn bullets pooled is going to do that's different, obviously, is we can still calculate a direction. So we can go dir vector2, what did we say? Vector equals vector2 up, I think is how we started this. Okay, so we want our direction. And we still want to do this same thing where we're calculating our angle. I'm going to go ahead and copy that. And I guess we need to calculate the radian angle too. I'm going to go ahead and copy this. But now I'm going to replace 5 with the bullet spread angle that I declared. Let's see, there it is, bullet spread angle. And instead of count, we're going to use the the bullet count, I think is what we called it. Yeah, bullet count. I might need to rename that, but anyways, that's the variable I'm referencing right there. Okay. Now what we'll do here is we're going to go through and it's going to look very similar right here. We're going to say I in, and then we'll do bullet count. Okay. We're going to go ahead and handle our bullets. Where previously with spawn bullets, we were instantiating the bullets and setting all that. Here, we're going to do something different. We're going to get a bullet from the pool, and then we will set the bullet variables appropriately, right? Because some of the things that we set in that reset, right, like our physics process needs to become true. We need to make it visible, and we don't need to mess with distance moved, but we need to set those other things, okay? So we'll kind of handle that in there. So to get the bullet from the pool, and ideally we might want to create a function for this. So let's go ahead and do that. We'll create a function down here that we'll call get bullet from pool. Now this is going to return a bullet, obviously, because that's what we want. Okay, so what get bullet from pool will do is it's just we're gonna find a bullet. And what we can do is we can just take our bullet pool, because the way I've built this, where we statically are just loading all the bullets to start with, we can just grab this at the bullet index, okay, which by default is 0, right? If we look at this. Okay, so that means it's going to grab the first bullet in this array, the first time that this function is called. And then we can just return that bullet, right? But we need to do one other thing, and that's each time we grab a bullet, we need to increase our bullet index so that the next time we call this function, it gets the next bullet. And on top of that, we want to make sure that as we set our bullet index, it wraps so that it doesn't go past the 30,000 bullets we have. Because if we hit 30,001 and then try and call this, then we're not going to find anything. We're going to get an error because that's outside the size of the array. So what we can do is we can say bullet index equals, and then there's a wrap integer function, wrap I. And what we do here is we provide the value, the minimum value, and the maximum value. And the value in this case is going to be the bullet index plus 1, okay, because that's the new value, and then minimum of 0 and maximum of, well, I guess we could just do max bullet count, right? Just like that. That way, if we increase the max bullet count, this will also change appropriately. So there we go. We've got a get bullet from pool. Now we can use that to get the next bullet right here. I mean, we could have put those like 2 lines of code in here, but it's nice to keep this separate. Then if you need to use it elsewhere, you can. Let's replace this with getting our bullet, get bullet from pool. Okay, now we have a bullet. And so now we need to do the next part, which is set the bullet variable. So we're going to say b.move direction equals, right? We want to set the direction just like we've been doing previously. So what we're going to do is this, just like we've done up here, right? We've set the dir rotated by the angle. I'm going to go ahead and just copy that. Yeah, so let's go ahead and paste that there. Okay, so we've got the dir rotated by the angle. And then let's go ahead and set our bullet position because we don't know where it is. So just to be safe, we'll set it to the bullet spawn location .global position, just like we've done before. We now also need to set the visibility. So b.visible equals true. And we need to enable the physics process. So we go b.set physics process, and then we can set that to true, like so. And we still need to increase our angle each time we do this. So I guess it's going to be just like this, angle plus rad angle. So now we've got a new spawn bullets pool that's going to pull from that pool of bullets. And so let's go ahead and run our game. I don't know if I've overlooked something. I don't think I have. So if we look at our remote and we look here, we look at all these bullets we already have. In fact, that's lagging this down to trying to scroll. So I'm going to go away from that. We've got a bunch of bullets. So now if I just click and hold this, oh no, that's not looking good, is it? Let's stop. Or let's go back to our script. Did we do the right thing here? Spawn bullets pooled. Oh, I see. Okay, so the error is obvious here that we're trying to assign a move direction to with something that was previously freed. That's the clue that I need to figure out what's going on here. In our bullet, we're queue freeing this still. So I forgot that we needed to go into our bullet, and instead of queue freeing it when it's moved outside of its move range, we want to call reset bullet. And if you recall, I actually went in and commented this, swapped that at the beginning of this video. Well, here we are. We got to come full circle and come back. Okay, so that's one thing to keep in mind, that when you're building a pooling system, your objects that are pooled need to be properly handled. And in this case, it's a simple reset bullet function call. Just make sure you're not queue freeing them if you expect them to stay in the pool, because then they won't be there. Okay, so let's go ahead and save that. And let's run the project again. Now this time, I'm going to go ahead and click and hold. And we shouldn't see any slowdown. That's looking good. You see how I can tell? I'm just keeping my mouse held so that it keeps spawning bullets. But you can see that the particle effects behind my ship are looking nice. And I can just click away like crazy. And I'm not getting any slowdown. Now this is only because of the one change where we're no longer queue freeing and then instantiating the bullets. Okay, now we're just pulling them from that pool. So I hope that that illustrates the benefit of using an object pool. And we had to recreate this kind of unique situation where an object pool is actually useful in Godot, because generally it does a pretty good job of handling memory. So, you know, if you're not going to have huge quantities of objects in your game, you may not need an object pool. But if you are, then this may help out with performance. So there we have it. That's the tutorial. Now, a couple things that you can do to take this one step further if you're going to implement this in your own game is you can try to build that dynamic pooling system like I mentioned. And again, just to reiterate, that's where you're going to generate or instantiate the objects as you need them, if you need them, and then add them to your pool. And then once you have a pool there, you may not need to instantiate them in the future. Another thing that I highly recommend you do with something like a pooling system is that you create some sort of an autoload singleton type scene that can handle all of your, in this case, bullet spawning. That way any entity, any object, whether it be enemy or player in the game, could call the spawn bullet and just provide the right values that it need, and it'll just get one from the pool and pop it in the scene. So I hope you guys learned something new, and if you have any questions or comments, please drop them in the comments section. And of course, it always helps if you give this video a thumbs up or subscribe to my channel to help me grow. And as a bonus, if you're a Patreon subscriber, this project and its source code are available in the Pixel Adventurer's Forge, which is a code repository that I've set up specifically for the use of my Patreon supporters at the highest tier. So you can check that out. And as always, we'll see you next time.